Hello, welcome to another video looking at river landscapes in the UK. In this video we're going to be talking about fluvial processes. Now fluvial is a fancy word for river, but because it's a word used by the exam boards in their specifications, you can expect to see that word appearing in exam questions. Now the objectives of this session are to be able to identify and explain the processes of erosion and transportation in rivers, to look at the reasons when and why rivers deposit material, and to consider how those processes change downstream. Now first of all, we can look at these machines to represent river processes. So first of all, rivers are eroding, they're picking up material. That material is then going to be transported downstream until eventually that material is deposited. So rivers break up rock, they transport rock, and then they deposit it. Now, first of all, when we think about erosion, linking back to last video, there are two main types: vertical erosion and lateral erosion. And the type of erosion depends on the height above sea level. So in the upper course, erosion is vertical. Remember, it's got that gravitational potential energy pulling the river down towards sea level, so it's eroding vertically through the landscape. But as we move towards the mouth, and therefore sea level, erosion becomes increasingly lateral, side-to-side erosion. Now, when we're thinking about erosion processes, there are four key processes you need to be aware of. Now, this video is very terminology heavy, but it's important you understand these terms and can define them. So, the first process of erosion is hydraulic action. This is the process where fast-flowing water in our river is crashing into the bed and banks of the river. That's the side and the base of the river, and as it's crashing into the bed and banks, it's forcing air into cracks, which causes that to expand and eventually crumble. Now this is particularly powerful at the bottom of a waterfall, where water's dropped from a large vertical height, or perhaps on the sides of a channel where it's being thrown around large bends. So we're going to see hydraulic action there. Another key erosion process in shaping the channel of a river is abrasion. And that's where material is being carried along by the river and it's banging into the bed and banks, acting like sandpaper, wearing that away. And again, that's particularly important in things on bends of rivers where material is being carried around. It's going to be scraping away at those sides, changing the course of the river. Our next process is attrition. Now this happens inside the water column. As material is being carried down the river, it's going to be knocking into each other. And every time we get a collision, it's going to be chipping the rock, it's going to be knocking bits of material off, causing it to decrease in size, but also to change shape to becoming something much rounder. So if you were to take a sample of bed load rock material in the river in the upper course, you often find it's much larger and it's often quite angular. But by the time you get to the middle and lower courses, that material becomes much smaller and also much rounder. And by the time you get towards the sea, at the end of the river's mouth, that material is often just very fine sand. Because the longer the material has been in the water column, the smaller it will get. It's been subject to more erosion. And our final process of erosion is limited to areas where the rocks are calcium carbonate based, either limestones or chalk like this rock here. So because river water, like rainwater, is very mildly acidic, rocks like this that are made of calcium carbonate can be dissolved very slowly over time by the flow of water. So this is obviously only going to affect areas where the bedrock is chalk or limestone. Next we'll have a look at our transportation processes, and like erosion processes, there are four that you need to be aware of. The type of transportation process taking place is going to be dependent on the size of the material being transported. So our first process is traction, and that's for material like this, large cobbles or even boulders. Because they're so large, they're not going to be picked up by the flow of the water, and instead will move along the riverbed by rolling. And that's only going to take place during really high velocities, high speeds of the river, and that will eventually allow these materials to be pushed very slowly downstream. Now smaller material, smaller pebbles can move by saltation, and that's where particles are effectively hopping or bouncing downstream. Every time the energy of the river increases, those small pieces of material can be picked up in the water column, but as soon as the water velocity drops, so too will the material. And so over time, that material is just bouncing downstream. Our finer material, fine sands and silts, are going to be transported in suspension. So these are floating in the water column. They can be transported in even low energies inside the water column because they are such small in size. And finally, same word for our erosion process, we've also got material travelling in solution. That's the dissolved material, the stuff that we can't see. So again, in our chalky areas, once this has been eroded, it will then move through the water column in solution. Again, we won't be able to see that because it's dissolved into the water. And then we get to deposition, when the river is dropping the material it's been transporting. And that happens due to a fall in the velocity, the speed of the river. And that happens due to a number of reasons. Firstly, the volume of water in the river channel falls. After a particularly dry spell, lack of rainfall, the water level is going to fall, therefore so will its speed, and so it's going to be depositing material. We also see deposition increased where we've had an increase of erosion. So a sudden input of material into the river, like at this river bend here where we've seen part of the riverbank collapsing, the river's not able to handle that much material and so it'll be immediately deposited. We also see deposition where the water level is much shallower, as we can see here on the inside of this river bend. So again, we've got shallower water, slower flow, and so material is going to build up. And the last example here is where the river reaches its mouth, the end point of a river. And that's usually a sea or a lake. And once a river meets what we call standing water, a sea or a lake is a standing body of water, the velocity drops immediately, and so we see sudden deposition. And that's why we can see these banks and amounts of sediment building up in this river's mouth. And then lastly, we'll just take a look at how these processes change downstream. So in our upper course and middle course, we're seeing lots of erosion. The river's got lots of energy, it's going to be breaking up lots of rock. So hydraulic action and abrasion are going to be taking place in that upper course. Transportation also changes downstream. Because the material is much larger in the upper course, we see a lot more traction and saltation taking place there. By the time we get to the lower course, where sediment has been travelling a much longer period of time in the river, it's much smaller, and so by now lots of it will travel in suspension. And deposition most commonly taking place in the lower course where it reaches the sea, where the energy level drops. So now we'll just take a look at some exam questions. Fluvial processes don't feature as large answer questions alone, although we often see that you will need to include knowledge of fluvial processes in larger questions when you're explaining the formation of river landforms. But we do see some short mark questions that stand alone about processes. And here's one. So it's a one marker, it says state one reason why the size of sediment carried by the river decreases downstream. Now it's a one marker, again, we don't need full sentences here, it's a state question, and in fact actually we could pick up a mark just for stating a specific process. So the reason why sediment gets smaller downstream is because it's been colliding with material. That's the process of attrition. So you could pick up a mark for saying attrition, a mark for describing that process, rocks colliding, bits of material breaking off in the water column. This next question is a multiple choice question about processes, and it asks us which of these is a process by which a river transports sediment. A and D are clearly both erosion processes, C refers to deposition, and B is the only one there that is our transport process, traction. And finally, we've got a gap filling question. Now, some people will look at this and see this as a really easy question. They're only easy if you actually have the knowledge. You can't blag this sort of question. You need to know your key terms. So yes, if you do know your key terms well, you've gone away and learned these, then yes, they are easy marks in the exam. So we've been given a sentence, a couple of sentences. We need to fill in these processes into those sentences. So sediment is moved downstream by rivers in a number of ways. Small sediment is carried in That's going to be suspension. Our smallest material is carried in the water column, while larger pebbles are moved along the river in small hops. We know that process is saltation. And then finally, large material is pushed along the riverbed by traction. So it's a 2 marker, all correct for 2 marks, 1 correct would get you a single mark. That's it for this video. Next time we'll be starting to look at river landforms, and we'll be starting by looking at the landforms created by river erosion.